This is Shelley. She works at the Smithsonian Environmental Research Center.
I'm a head technician of a lab, so I'm basically like a lab manager. So I do like all of the ordering of supplies and keep everything inventoried and take care of more of those like administrative type tasks. And then I'm also like the lead field assistant. So yeah, every day is a little different, but that's what keeps it exciting, I think.
Right now, she's working on microclimates. Microclimates are small changes in scenery that will create differences in how areas are affected by climate change. In the Maryland and Delaware area, microclimates are usually affected by their proximity to water or topography. So how does Shelley find data on microclimates?
So the microclimate sensors are measuring, they're really small, they go in the ground, and they're measuring above ground temperature right at the soil surface, and then like 11 centimeters above. And then they measure the temperature below ground and also the moisture below ground. Because if you're like a little beetle on the ground or a little frog, you're experiencing sort of like a different microclimate than, even someone that's taller, like a tree around you. So we're trying to characterize what those microclimates look like to get a more detailed understanding of what animals are actually experiencing when our climate model might say, oh, this area is warming by 1 degree Celsius.
Understanding how different areas in particular will respond to a changing climate helps the citizens adapt and view the problem on a smaller scale. But microclimates aren't only helpful when thinking about humans. It's important for animal species as well. And the animals that can tell us the most about microclimates are bugs. Why? For one, because of their sheer numbers.
Insects are extremely abundant. It's estimated that about half of the species on planet Earth are insects. About 1 in every 4 animal on Earth is a beetle specifically, so there's a lot of beetles out there.
Insects are also incredibly susceptible to the dangers of generalized climate change research. In a 2015 study in Costa Rica, it was found that bugs live at different heights based on how well they can tolerate heat. If a scientist was looking at the area in general, they would only see one temperature for a climate projection. But on a bug-sized level, even a little change in elevation would make a large difference in temperature. It's important that climate change research takes bugs into account because they support our entire ecosystem.
They do almost like everything in nature you can think of, right? We have like herbivores, we have predators, we have pollinators, we have decomposers. So they're kind of doing all of these different roles, and they're often neglected or seen as like pests, and some of them are definitely pests. But they're also doing a lot of beneficial things for us. And I think like bees get a good reputation, everyone's like, save the bees, but there's so many other types of insects that are doing beneficial things for us all the time that sort of go unnoticed.
Shelley is optimistic for the future, but she wants to see more urgency in our perception of climate change.
I mean, I think you have to remain hopeful. Otherwise, there's nothing's going to get done, nothing will change. So I am hopeful, but I'd say in my line of work, talking to my peers who maybe are in like more like business type things or, just not science focused or don't know that much about climate change, I see that they're like, oh, that's going to happen in 50 years. Like their sense of urgency is a lot different than mine.
Hopefully, if our climate education becomes more specialized with the help of research like Kelly's, we will see communities learning how to become more eco-friendly together.